Welcome back, everyone. Let's continue surprising ourselves with interesting Java specifics when it comes to floating point numbers. So, first thing we saw in our previous video recording is that when we divided 1 by 0 as an integer, we got an error, we got an exception saying that you cannot divide by 0. However, when we divided by 1 by 0.0, which automatically converted this variable to a double, right? We got a string infinity, and we did not get an error, okay? Of course, if you try to do something else after this, you will probably get an error, but we will look at why 1 divided by 0.0 or 0 in Java is not an error but an infinity. And the answer to that is 0.0 is not really 0, okay? Now, what do I mean by that? I don't want to confuse you. I want to show it to you. So let's go ahead and create a new class. Go ahead to your section, go ahead to on your package, right click, new class, and I'm gonna call this class precision errors, and I'm not gonna add in Java. I'm just gonna keep it there because we're working on Java anyways. So call your new class precision errors, finish, open up a space, declare your main method, public static void main string args. Now, let's do this. I'm going to show you how when we wrote when we talked about float, we said this is a single precision, right? And when we talked about double, we said it is double precision. In the previous example, in one of our previous examples, we divided two numbers, and one of them was 3. Let's recreate that situation. We said 11.0 divided by 3.0, and instead of getting 3.6666 and 7 at the end, we got 3.666 and 5 at the end. So it got rounded for us, but it got rounded to the wrong end of the gauge, right? So it was supposed to be rounded up. It got rounded down because there is a lack of precision. Look what happens if I do F. When I say F, these two numbers are not double anymore, right? They are floating numbers. Let's run and see what happens. Now, in that case, for some reason, we got actually a closer answer to what we were supposed to. Okay, so you see, this is something related to how floating point numbers are calculated in Java binary. Okay, one more example is, so if I say in a comments 1.0 is equal to 0.1 plus 0.1 plus 0.1, you get the idea, right? So 10 of them. Do you think this is going to be right for Java? Let's double check. So we're not gonna be lazy. We're going to actually print 10 times 0.1 plus. So let's copy it. Let's use one shortcut at least, copy. So this is the second, third, fourth, fifth, sixth, 7, 8, 9, 10, right? And let's close our statement, at the end by adding our semicolons. So there are 10 0.1s here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Correct? So this total should be equal to 1. Correct? Run. No, it's not. So what happens is somewhere here in one of these, or maybe multiple of these double values, Java rounding has an error. This is called a rounding error. That's why when we looked at float and double, we said that do not use float or double for precision calculations. Now you're going to ask, then how can I get a precise calculation? Let's say you're writing a bank application, you're developing a bank program. How are you gonna be sure that if your initial account is 123.45, and if you add 0.01, if you add 1 cent to it, you're gonna get 123.46, right? So after demonstration of this, you know that if there are more than 1, 2, 3, or maybe certain number of operations, Java is gonna mess it up for you. And then you're gonna have rounding errors here, rounding errors there. And at the end of the day, after 5 operations, the customer will look at their bank accounts and they will find out that they're missing 2 cents. So that's gonna be a lawsuit, and that's gonna be tough, right? So programmers, knowing this weakness, actually opt out to working with integers. That's why integer is your default number value. So if you are to develop a bank account, the bank account operations related program, you're going to store this $123.45, let's say account balance, is going to be equal to not 123.45. This is not going to work because Java is going to complain saying that you cannot have floating point number declared as int, but you're going to store it as 12,345 cents. So let's put a comment. $123.45 is equal to 12,345 cents. Sorry, $123.45 is equal to 12,345 cents. And now if you want to add int deposit is equal to let's say $3.59, right? You can't do it. 359, and we're gonna call it deposit 1. So let's do this. 359 is equal to 359 cents, and let's say int deposit 2 is equal to 3 cents. For some reason they decided to add 3 cents to their balance, is equal to 3 cents, right? Int withdrawal is equal to, for example, 99.99, or let's do this, 129.99. They decided to purchase an Amazon account, Amazon Prime. So $129.99 is equal to 12,999 cents. So if you do int result is equal to account balance plus deposit 1 plus deposit 2 minus withdrawal. Now system out, result. Let's see what happens. Run. You get 292 negative, and what you need to do is, so we had deposit minus 359. Yeah, it was like $3. Yes, obviously you're gonna get charged an overdraft fee because basically you have negative 292 cents. What if you wanna declare it as a what's its name, dollar amount with cents? So you're gonna take this result, divide by 100.0, because 292 cents totaled divided by 100 is going to reveal 2.92, and that's how you're going to get your precise balance. Okay, of course bank programs are not going to be simplistic like this. Down the road we will see how we can take these numbers from the user, not by inputting here. We will see how we can round these numbers and all, but this is just to demonstrate how you should do precision operations. If you want to do the same, let's just take a moment and rewrite the same code with doubles, right? Double dep1 is equal to 3.59, double deposit 2 is equal to 0.03, and double withdrawal is equal to 129.99. And if I say double output is equal to balance plus deposit 1 plus deposit 2 minus withdrawal, and I can't use withdrawal, I'm going to say withdraw. I can't use withdraw because I used it before, right? So withdraw. Then if I print lane output, let's see if I'm going to get exactly 2.92 instead of something else. Let's run it. And voila, you're getting 2.92 and some change. Eventually, after maybe 100 operations or 1,000 operations, if you use double in your calculations, if you use floating point variable in your calculations, this is going to be a huge headache for you. This is just to declare the weakness of like lack of precision in Java's floating point numbers, and we're going to stop it at this point, and we will see you again with other specifics of other arithmetic operators in Java. Thank you very much for your time.